Yeah, I'm
Hello,
gonna mute.
and
Hey, how you doing?
welcome to our second Notional Pipe live stream on componentized rigging. Let's see. I think I'd like to start out by actually going over again some of the stuff that we kind of talked about last time, but I felt like I didn't do a very good job describing it, and I was a little distracted last time, and so I ended up talking in circles a lot about like all of the problems with auto rigging, but I didn't necessarily make it clear enough. I think just what componentized rigging is and what it's good for. So let me do that. I am going to draw a diagram. Basically, the concept of componentized rigging, which again, I don't think I necessarily explained as such in our previous thing, is that you've got these chunks of rigging and that they present an interface to the rest of the rig. And I did say that, but what I didn't do was draw some little boxes, which is always helpful. So in this case, what we're going to do today is we're going to start by attaching some fingers to a hand. And what that means is we have, if you think of it as this box, an arm and a bunch of fingers. Let's say there are 3 of them, because apparently that's the kind of cartoon character we're doing. And then we have a spine. Now, each one of these boxes represents essentially a chunk of rigging. And each of these boxes has these defined inputs and outputs. Specifically, in this case, all of them have sort of a parent input. That's the anchor that we were looking at before and that we're going to be taking a closer look at here. So you can think of it as, if you wanted to think of this as being like a visualizable node graph, which it's not really because Maya doesn't really know that these are units, right? Um, each one of these has a little pin for what am I parented to, right? And that anything in theory, but in this case, like the spine controls the arm controls the fingers. But the important part about it, which again I'm sort of belaboring the point, but I want to sort of like make a point of it and get to the meat of things in a way I feel I didn't before, is that everything inside any one of these boxes, the rest of the rig cannot know anything about it or do anything about it. The important part is that you're choosing, because Maya won't really enforce it, you are choosing to say, I'm not going to edit anything inside one of these boxes. Um, inside, except by modifying the box itself, which lives in another file. And referencing is what we're going to be using to set this up so that you could have multiple arms referenced in, right? And each one of, but we have specific ways that are predefined to have the different boxes communicate with each other. And this essentially is part of why componentized rigging gets you all of these advantages of auto rigging, i.e., you could rig repeatably without all of these disadvantages, because since there is a live connection here, right? But one that you already know what it is, which in the context of of conventional auto rigging, you generally you what you end up with at the end is a bunch of nodes, all of which are connected to each other in fairly complex ways, and usually without an understanding baked into the rig in any way of where the communication is between different sorts of modules of the rig. It's just, Maya sees things as this, big massive nodes, all of which are, connected to each other, and it doesn't have any way of differentiating what means what. Um, what componentized rigging does is enforce a case where you know where the borders are. You know what the interfaces are between different chunks of rigging, which means that that's why you can swap rigs out or change the proportions of a rig without actually needing to rebuild anything. So what I've drawn here is actually very much a simplification, because there are other inputs to each one of these things other than the what is its parent in the rig. There are also the guides. So each one of them has I'm going to make the guides like a sort of oblong-y thing. Apparently I can't write while I'm holding my hand out like this. But anyway, the point is that what happens inside that box is wholly dependent on the inputs it receives from other components in the rig and from the guides, and is not modified in any other way. And that's what gives it its flexibility, that you generally can't have in the context of auto rigging. So I just wanted to take a moment before we went further to sort of go over that again, because again, I felt like last time it just wasn't that clear. And I was at the time just like, I don't know, I'd had a long day. But now that we said that, yeah.
So for me, I mean, I guess I'm a little bit curious about the guides, but I guess this is something that we're going to get to, is looking more closely at how these guides work, right?
It is, although I actually think it wouldn't be a bad idea to discuss that a little bit now too, because I was going to move on to the relationships between things in the rigs. We talked a bit about the guides last time, and I put together some guides. But now wouldn't be a bad time, I think, to return to that. So yeah, go ahead and ask.
Well, I guess maybe if you could just give something of a conceptual overview of the guides and how they work.
So the idea internally, if we're going to open up one of these boxes and look inside it, what's inside the box is inputs. I'm just going to call it in. I am doing a terrible job making this comprehensible, but we'll just go with it. We have inputs, and then we have all of the stuff that the rig does, which is probably like a whole bunch of nodes and joints and handles and like all kinds of stuff. There's a whole node graph happening inside the box that nothing outside the box knows anything about, and then it goes into the outputs. So the inputs can come from other components, which includes, the parent, for instance, is probably the most obvious case here. But the input can also come from guides, and what the guides do is essentially just feed in matrices. So each one of these guides is just a locator, and it's just going to feed information into some of these inputs that are being used, and this is what we were actually setting up last time, to set the bind position of the joints that are internal to the rig. So you have, among other things inside this box, some joints. And by taking these matrices that are being fed in and turning them into, say, bone lengths, next joint orients, and direct orientation of some transforms, you're essentially doing all of the stuff that an auto rigger would normally do, or that you do manually if you were building a rig, to set what the character's proportions are, to set what its bind state is. But instead of doing that by setting that data, you're connecting that data into some of these inputs, which can then be driven by guides. That's what makes it something that you can simply modify on the fly, instead of building a auto rigger that is going, or doing it manually, which is going to set data in all of these places in such a way that it's quite difficult to go back and change it.
Okay, so if you wanted to make a change, you'd change the values on the guides. I mean, you'd go directly set those, and then you'd have to rebind, right? Because your bind position would have changed.
Indeed, your bind position would have changed. I mean, one of the ways that you can do this, you just enter, in Contour, this is very easy. You enter rebind mode, you change the position of a guide, and you exit rebind mode, and there you go. Well, it's very, very simple, right? If you're doing it with conventional joints, you usually have to do something a little more complicated to reset the bind data, but it's not a huge deal. Yeah, you do of course need to reset the bind after you do this, but it has been, for instance, so I wrote a componentized system for the third floor, which we're using right now in production, and the degree to which we can be like, we didn't quite put these joints in the right place, we're just going to enter a mode, tweak it, we're done, is really been extremely helpful. Traditionally speaking, not that you can't change character proportions in rigs, because you absolutely can, and of course people do all the time because you can't avoid it. But what traditionally speaking, it usually means rebuilding the rig, and that's an enormous hassle for a variety of reasons. A lot of the time, I mean, there are some quite powerful systems that have been developed around auto rigging of various kinds. One moment, I just need to answer someone's question. I am technically, like over a TTF, there's still, this is the workday, and so people may occasionally have questions for me that I absolutely have to answer, but it should only take a moment. Yeah, there we go. So the where was I? I was saying yes. So you basically have it's just incredibly helpful. And it takes so much effort out of the work of building rigs. And it's why when we traditionally you get this thing where you're like, oh, like way down the line, right? You're about to start animation, and you're like, oh no, I need it comes down from the director, whoever's in charge. Oh, we're going to make a change to the rig, and normally that's like, oh my god, because if you have a well-designed system, you can certainly rebuild, but you're often going to encounter those issues where it's like somebody had to make some change, or it's something that might even be difficult to do in the context of however your system functions, and it's difficult to rebuild. Like there's so many issues that just don't happen here.
Yeah, I mean, this intuitively makes a lot of sense to me because, we've talked about this quite a bit in the past, but, rigging is a form of programming.
That's right.
But at least as things stand, you simply do not have the tools as a rigger to abstract and encapsulate in the way that programmers do in programming languages.
Exactly. And what this essentially is an attempt of providing artificially some abstraction. Now, last time when we were talking about this, I did mention that there is a way to provide actual abstraction in the Maya node graph, and it's actually what Rafael Fragapane, who really pioneered a lot of these techniques, has used. And they are these assets that try to be black boxes and present like specific attributes that can go in and specific attributes that can go out. That's enforced by Maya. And the reason why I don't do that is not because I think that's a bad idea. I think that's an excellent idea. I think that's exactly how the Maya node graph should always have worked. It's because the reason why I don't do that is that it's not very well supported. It's sort of an afterthought to Maya, and the interface for interacting with those things, and the API for them is kind of ugly, and I'm not sure what its consequences are going to be, because like many things in Maya, it sort of has been a feature that's hung out for a while, but if it's not widely used, they're not paying an enormous amount of attention to it. So I ended up making the decision not to use assets in this, for doing componentized rigging. I am simply adding these input and output nodes myself, and then making a commitment. Making I have made a vow never to connect anything inside a box to something in a different box, right? But it's purely self-imposed.
And so these inputs, do you have like one node that's just
Indeed.
responsible for routing all of the inputs into the appropriate stuff within it?
That
Same
is
thing with
exactly
the outputs.
what it is. Let's go back to our ARM example, which is like a fully constructed componentized rig. In these components, and you could see me doing this a bit beforehand, where I was hooking stuff up to the inputs node. Here's a bunch of matrices. These are matrix attributes on these inputs. Everything that enters the system has to go through these inputs. That's a rule. So anchor and anchor offset are the ones we're going to be considered with today. Clavicle, elbow, shoulder, hand overshoot. Like, these are all things that we're going to be using to figure out, those are where your guides get plugged in. But then you also have these various like character upper body and upper body offset. We'll be getting to those. These are about spaces. Because, of course, one of the things you need in a rig often is space switching. Now, of course, we have strong opinions about space switching in conventional rigging. Ephemeral rigging doesn't need any of that. But if you're not using an ephemeral rig, and you're not because that's, we haven't like released it or anything, then you kind of are still stuck needing space switching. So just like anything else, if something inside your box needs to know something about the outside of the box, it needs to know what the upper body's space is in order to be able to do space switching to the upper body, then that must be an input. Now, one of the things that we're going to get into right now, actually, is why there are these offsets, because that has a bit to do with how the box actually behaves. What the like how you deal with taking all of these matrices that are being plugged in and composing them. And so that's actually one of the things we're going to be dealing with immediately. But yeah, the concept here is that nothing is allowed to touch this rig except through the inputs. Now, the outputs are actually a slightly different case here, though. So the way that I have often constructed componentized rig systems is that there is also an outputs node, where essentially the same situation, right? You then you have outputs, and those outputs are the only things that are allowed to connect into other aspects of the rig. And I probably will end up making an outputs node, but I may not necessarily make the same level of stringentness about that, and here's why. When doing so, it often means duplication, which is actually perfectly fine. I mean, you're allowed to duplicate stuff. And in this particular case, for instance, if you want to use one of the advantages of Contour, which is to say your bones can also be controls, you are kind of not able to do that if you're relying purely on outputs, because you can't bind to anything inside the box, right? That would be a violation of your inputs and outputs thing. But that means you necessarily need a duplicate joint chain, right? You've got one that's inside the box, one arm that's inside the box that can do FK and IK and all this other stuff, and you've got one arm that's outside the box being controlled by the outputs from the arm box, and it is what you actually get bound to. And that adds complexity to the rig that I don't necessarily love. And it's worth it in some cases when you want a system that's going to be maximally modular. Right, so this, when I build componentized rig systems, I often build things that are intended to be extremely modular. Like, you're going to stack a whole bunch of these things on top of each other. For this purpose, though, when we're talking about essentially body plans that we want to present to users that are going to use Contour, I'm less sure that that's the right thing to do. I don't want these rigs to become over complex. So in that case, I may consider binding to a joint chain to be a valid output, essentially. Because, again, what you consider to be a valid input and a valid output is essentially conceptual, right? Nothing in Maya is going to ever enforce any of these things anyway. And I think that's actually going to be a simpler way of doing this particular thing. That doesn't necessarily mean that it's what you'd want to do with any sort of componentized system. Componentized systems that are made to be as flexible as possible probably should not do that and should simply duplicate joints. But we will still need some outputs here, though, because we're going to need to parent stuff. So actually, here we are in the arm. We need to make a modification to the arm. Let's do that right now. I am going to make an outputs node. And the reason why I need an outputs node is if I'm going to drive the fingers, I need to know the current transformation of the output transformation of any of these controls, specifically these various joints. Now, I don't need, for the fingers, I only actually need the hand, but because this is meant to be fairly generalizable, I should basically have hand, shoulder, clavicle, like everything that you would expect. So let me go do that. And as you may recall, you cannot actually make matrices in Maya via the matrix attributes, that is, in the UI. As far as I know, like, occasionally I discover stuff in Maya that I actually don't know anything about, but, sometimes usually speaking, I do know about it. And in this case, I am going to have to actually type a thing to do this, which for me is very natural, but I know that it is sometimes confusing to people. So I'm going to grab this and I'm going to say that's me getting the first, I'm getting the selection list and taking the first item in the selection. So that's the thing I have selected. And I'm going to say add, using PyML here, add adder, calling, the adder is going to be called hand. I don't need to call it like hand output or anything because it's on the output node. So we know it's a hand output, right? I believe it is data type. Occasionally this is confusing because there's also attribute type and it depends on what you're trying to make. Can I make an basic attribute like that? No. probably for exactly that reason. Oh, wait, no. I probably just typed it wrong. Yeah, that's what it was. And here we go. Here's our hand matrix node. So that which corresponds to our input. So we need also elbow, shoulder, and clavicle. All right. And here's how we'd hook those up so that they can be exposed to the rest of the rig. Now, again, this is something I often write code for, but in this case, I'm not going to do so. You know, close these. In this case, I'm not going to do so because I want to make it a little clearer. And all I need to do is I need to get these outputs and grab the things that are going to go into the outputs, which are actually our contour joints, right? Which are also animatable controls. So this makes it very easy because usually when you have like FKIK systems, you've got some internal set of joints that are going to be doing this, but it's a little more complicated. In this case, it's contour, so the joints and controls are the same thing. And we can just bring them in. And keeping in mind that in order to make it easy to hook things together in this way, we are always getting world space matrices so that we can decide on the other side of the divide what we're supposed to do with them and what space we want to do it in. It's just the simplest way to do it. We need to get its world matrix. Come on. Yeah, you didn't want to do that, huh? There it is. See, the node editor sometimes leaves something to be desired. That's the shoulder. There's the elbow. And here's the hand. So these outputs now are going to, basically get the world space matrices of each one of these controls. Now, here's what we need to do on the other side. And here's where I actually think it gets kind of interesting. Although people often, for good reason, don't always like reasoning using matrices because it's very easy to get it wrong. And when you get it wrong, it's very confusing. And that's very understandable. That said, I think that reasoning using translate, rotate, scale values and any of the other ways that we normally think about things in rigging is actually significantly worse. And what we really ought to be doing is thinking in, taking the pain that sometimes happens in thinking in matrices, because it can absolutely confuse you when you get it wrong and get a wacky result that you didn't expect. But accepting that, because it actually ultimately, when you get past that pain, is just a vastly simpler way of thinking about how transforms relate to each other, and is actually the way that actually underlies everything happening in Maya. The whole thing about these transforms being essentially like translate, rotate, scale values is kind of a lie, right? I mean, they have translate, rotate, scale values that are all derived from a matrix or used to construct a matrix. Like, it's all matrices in the end. Oh, by the way, before I move on to another thing, I just wanted to show an example, because we were talking earlier about guides and the live relationship of the guides. So this is a perfect example of the live relationship, right? I can just move this guide around anywhere I want to, and it will change the proportions of the rig, and I am actually changing its bind state, right? I am changing its default state in real time. This would be the equivalent of like remaking, rebuilding an auto rig like every evaluation cycle, right? It would obviously be a crazy thing to do given the way that auto rigging works, but in componentized rigging, this is very simple and easy. All right, let me go get a finger. And let's see. Yeah, here we go. Did I Haha, I was thinking about legs at the time, and I must have accidentally named the file leg, because we definitely didn't make a leg yet. Finger. That's what I want. All right, here's our finger that we made last time, and we are still referencing in the arm essentially as a reference. Like, I wanted to kind of be able to look over at the arm and be like, oh, this is how I structured the various things in the arm. So in this case, the arm component now shows that we have an outputs, which we did not previously have because we just changed it. And we will need a similar thing for the fingers. But before we do, here's what we want to do with fingers. We want to figure out how this anchor ought to move around. Something we got to do for the arm too, actually, because eventually it'll have to be hooked up to a spine. This anchor, and which I apparently misnamed, so let me fix that real quick. Come on, there we go. Yeah, this anchor, not Archer, or Arcor, or whatever that was, has to move with the parent. Now, here's where thinking about things in terms of matrices is going to be really useful to us. Because we already have a whole bunch of world matrices coming in through inputs. We've got our joint 1, joint 2, joint 3. These are coming in from the guides. The guides, and it's why, we can, just like we could with the arm, we are changing the bind state of the mesh. Or what am I saying? The mesh. We're changing the bind state of the rig, right? Just by manipulating these guides. The data just sort of flows through the rig and changes the things that need to be changed. Now, the tricky part here is that because all of those matrices are world matrices, and it's highly desirable for us that they are, we are already doing some work to change what space those matrices are in. We did all of this last time, so you can sort of see what we're doing there in order to apply them to something that is in a hierarchy. So this set of contour joints that we're controlling, it's a hierarchy of stuff. That means that our world matrices need to be multiplied with each other appropriately in order to produce the right values to be put into a hierarchy. And we already did all of that work. But as a reminder, let's take a look at this. So if I go to the node editor and I take a look at the outputs of inputs, here's where we were doing all of that work. And it's actually not that complex, especially when you ignore the decomposed matrix, which is only necessary because of how we're putting that data onto the bone, or alternatively, because we don't have offset parent matrix. But basically, the idea here is that you take, say, joint 1, the matrix of joint 1 in world space, keeping in mind that this is not going to move around during animation, because this is what the guide is outputting to. We want to multiply it by the inverse of the world matrix of the thing previously in the hierarchy, or that is driving the thing previously in the hierarchy. And then that will essentially just give you what that transformation is in the space of its parent, which you can then simply set your bone and joint to represent, by, in this case, length and next joint orient. Now, this is often, and I don't quite know who my audience is, for a bunch of people who probably are interested in this, what I'm saying is like 100% normal and like nobody's surprised, right? You guys all know this, but plenty of people who watch this channel may not be familiar with these concepts, so I do kind of want to explain it a little bit more, which is that this is exactly what happens when you parent one thing to another thing in Maya. If you have here, let me just throw down some things. I've got my sphere and I've got my cube, and I'm gonna like rotate them around. If I were to take the sphere and parent it to the cube, but I were to do it relative, which does not try to compute what its current world space position is in the space of the cube. So if I were to be like, right, then it's going to jump, because it's basically saying the relationship, like the values that I have, the matrix that I have, right? My transformation is relative to world. And now if I make it relative to something else, it's basically considering the cube to be world. If I wanted to not change its position, if I'm just going to parent it the normal way, hitting P, then, and it did not change its position, what Maya is actually doing there is, before it goes and actually changes its parent, it is multiplying the sphere's matrix by the inverse matrix, world matrix of the cube. It doesn't matter in this case, world matrix and of the cube is the same thing as regular matrix because it's just in world space. But if it was in a more complex hierarchy, it would matter that it was in world space. So this is exactly the same math. And one of the things that I find very helpful when reorienting one's mind, right? This was sort of my experience when I first got into thinking of things as vectors and matrices instead of, translation, rotation, and scale, is just to remember that this is all basically parenting. It basically, this is what parenting is, actually. And therefore, it gives you an experiential basis for thinking about what this stuff means. In this case, we're taking two world space matrices, and we're putting one of them into the space of the other, which takes the world space matrices and turns them into something that we can pop onto this hierarchy. So what we're going to need to do now, though, is to have yet another thing that can affect how that hierarchy behaves. Because it is not merely the guides that are going to change the, if you want to think about it this way, default position of these transformations. They also have to be moved around by their parent. One of the ways to do that would be to get the parent's world space matrix and do a whole bunch of stuff where every single one of these things included a bunch of additional nodes. And that's, a valid thing to do, but I don't really want to. And there's a simpler answer. And that's what this anchor exists to do. So what the anchor is it is something that is always at it's always identity, as they would say, which that's math talk for it's at 0, 0, 0, 0. And we need something like that for these world space matrices to be relative to, that will nevertheless move around with the parent. That's going to be simpler than just making each and every one of these things be more complex. And here's how we need to do it, keeping in mind that the anchor must always be identity in bindpose. Like that's sort of a foundational idea behind how these things are being moved around. And how we can get away with simply using these world space matrices without doing a more complex thing to them. So here's what we need to do. We're going to bring the anchor in. We're going to get both the ARM inputs and the ARM outputs. And this is actually a pretty important aspect of how this is going to work. I'm sorry, what am I thinking? Not the ARM inputs. We're not doing the ARM. The inputs, we will ultimately be hooking these things up in the context of a, sort of a body plan file, right? But we don't need to care about that. This is just here for example. I don't know what I was thinking. We do need to take these inputs. Now, we need to actually add some additional inputs here. Let's see what we called them on the ARM, because they do need to be consistent. We called them anchor and anchor offset. Do I want to call them that? Or do I want to call them parent and parent offset? I already called this thing an anchor, so I guess this is fine, actually. It's always a little unclear how you should name things in order for best clarity, So yeah, let's go add some additional things to this. Here's our anchor and our anchor offset. So, our anchor, what's going to be plugged into this input, is going to be the current, potentially animated, and therefore not in bind pose, location of the, matrix of the thing you're parenting it to. In this case, it would be the output from the hand, right? Anchor offset has to be what, and here's why it's important. Anchor offset has to be what the input is in the input to the hand would be, right? The guide that's driving the hand itself. And the reason why these two things are important is in order to be able to sort of undo the transformation in bind pose. So you've got a hand, the hand's somewhere in space, right? you want to offset that so that in its bind pose, there is something that is essentially parented to the hand, but is actually back at the 000 world location for all of these fingers to be parented to. But then when you animate it, when you move it around, you want it to be moving around the fingers, of course. So that's why we need both an anchor and an offset. And here's how we would go about doing that. So we essentially take the offset, and the offset is going to be inverted. So we're going to use an, here we were talking about how matrices are sometimes frustrating, though. I'm probably going to get the order of this wrong the first time. Like it's almost guaranteed. Let's see if I actually do it properly, because I probably won't. I need a mult matrix. I take the, plug that into matrix in. Plug the inverse matrix into, no, I think that's wrong. I think it should be the other way around. Because what I'm essentially doing here, no, that is not what I was trying to do. That should not go on there. This should go there. There we go. Because here's what I'm doing. Usually when it sums up this list, it's basically like first item is parented to second item and on down the list, right? So by inverting the matrix, nah, I got this wrong. I did get this wrong. Here, let me just do a little test to ensure that I am correct, that I got this wrong. Because if we have it up here, and let's just do like a little tiny bit of additional rigging to sort of express how this works, right? So let's say that that this cube here, right? I'm going to take this cube and I'm going to grab its matrix. Doesn't even matter if it's the world matrix, and invert it. Actually, I just grab the inverse matrix off of it, and I'm going to plug it into cube 2. So here's cube 2. Going to need a decompose node because this is Maya 2018. Pop the matrix, the inverse matrix in there. Put the translation, rotation, scale. All right, so note that it definitely did not reset this thing to 0. What it did, and this is actually a really good description of how, well, I mean, it's sort of hard to see, but here, I'll actually scale it, and you'll see that will change things quite drastically as well. But I think that if I don't, it's a good description of what inverting a matrix actually means. So if I want to have something that's always parented to this, but is back at 000, the order in which I need to do those things is a little different. Because, watch what happens if I parent this to this one. Now, the effect is that no matter what I do, it stays at 000, because that's the effect of the inverted matrix. If you invert a matrix and then essentially parent it to itself, you're essentially returning it to world space 0. Which is a very, very nice effect. Oh, and that is what I did here, actually. I thought I'd screwed it up and wanted to sort of explain why. But it turns out I actually did get this in the right order the first time, I think. So hopefully this actually does what it's supposed to. So let's see. So now what we need to do, let me get rid of these cubes because their thing is not important anymore. Because essentially the thing I did there with the parenting, this is exactly what's happening here, right? I'm getting the anchor offset, keeping in mind that the anchor offset is going to be the bind position of the hand. I'm inverting that, but then I am parenting it to the current position of the hand, i.e. the one that's animated. And this is what gets you something where it is back at 000, but only at bind pose. Hopefully this will all make sense soon enough. And then we're going to just output this into anchor. Let's see, we want to decompose. Couldn't possibly have figured out that matrix sum goes into input matrix, clearly. And let's hook these up Keeping in mind, very important, even though it's not always obvious, that you hook up shear as well. Otherwise, you are likely to get messed up scale results at some point. Shear is actually something included in an actual matrix, and if you want to ensure that you are actually properly doing the equivalent of driving this matrix directly, you must connect all four of them. So, let's try actually setting this up. So here's what I'm going to do. I am going to remove what the hell am I doing? Sorry, reference editor, that's right. I'm going to remove that reference. Here's our finger without any additional stuff that we were using purely to see. Yep, and it's got the guides. So let's put together an example body plan file. Here's what we're going to do. We're going to reference in the arm, and we're going to reference in a finger. Now, the position of this arm, like if this were, you're thinking about this like this is an actual character, what you'd be doing, because I think, yeah, that is how I set it up, is, your arm would be up, like, you imagine your spine's over here or something, your arm's way up in the air somewhere, like, I don't know, and then the finger, similarly, has been positioned, there we go, somewhere at the end of the arm. So here's what we need to do to make this work. Because right now, if we hide locators, the locators are telling us, and just to show that, I'm gonna like actually change the proportions because I love doing that. The guides are telling us sort of what the world space. I grabbed the wrong one. What is the world space shape that this thing takes on, right? What are its default proportions in world space? And that is one of the reasons why the guides can be parented to each other or anything else. Like, we can do whatever we want with the guides. It doesn't matter. It's all world space matrices. Here's your finger. I just adjusted it somewhat, like, for purposes of seeing what that means. But obviously right now, I'm going to hide the guides, and I'm going to use, here I'm just using IK. I'm just moving around my arm as you would animate it, right? Finger obviously does not go with it. One thing we absolutely cannot do in this system, it's incredibly important not to do it, is we don't actually constrain this to the finger or anything like it, right? Because again, the boxes can't talk to each other except by their like little interface things, like except by the predefined ways they're allowed to talk to each other. So here's how we do it. Let's bring back up our node editor. Let's do, we need finger inputs. And once again, I know I've said this before, but like when doing this in practice, I don't usually connect it all by hand. I have little bits of code that do it because it's a lot faster, but we are going to take our ARM outputs and ARM inputs. Now, remember here, what's driving the ARM inputs are the guides, right? When I am, let me just put the guides back on. When I am moving the guide around, that's, the way that it is making any of the adjustments it's making is changing the data inside these inputs. The outputs are what's coming from the controls. So as long as a control is in default position, as long as it's zeroed out, the inputs and the output world matrices will be identical. The moment, of course, you animate it, they diverge. Right, it's in IK mode right now, but now they're different, right? So what we want to do, here's another way to express the thing I was doing with that inverted matrix, is that it is the difference between the ARM inputs and the ARM outputs that produces the transformation that moves the finger around. And the way that we get to do this, and again, chances are I actually screwed this up in some way at some point, and it will be broken, but let's see, is that we want to take hand, and we are going to plug the hand input which is going to totally appear to break things at first, but let's go with it, into anchor offset. And the hand output, yeah, see how the hand actually disappeared and you can just see the guides? Because, you know, we're not feeding the right data in yet. Here, let me just turn off locators so you can see that it went back to 0 because, hey, what's relative to, this is actually very instructive. Note that it is in the same arrangement relative to 0 right now, relative to world 0, that it would be relative to the hand if this were happening properly. Now let's take our hand outputs, which is the actual current position of the hand, and plug that. See, there were many things you could have theoretically plugged it into. I don't know why. It happened to be correct, but really, Maya, you probably shouldn't do that. Note that here we go. Now we have the finger back where it's supposed to be. Let's just double check that that's true by turning on the locators, but it sure is. And now it is parented. Because effectively what this does, right, what this is doing, and the reason why I prefer this to complicating the node graph inside the component, is that what we are saying is, in addition to all of the transformation that is being sort of input into the finger, into each individual finger joint, the whole system is being moved around by the difference between the arm inputs and the arm outputs. And it is actually, I mean, I feel like this is actually like a really valuable sort of rigging concept. Like there's a differentiation here, a clear difference between well, all right, let me find a better way of saying that. When you can make something in a rig depend on, as essentially happens all the time actually, the difference between two clearly enumerated things, this often is a good way to think about things in rigging. It's often very valuable, right? You know, you can you know, I mean, ultimately, for instance, this is how all deformation works. It's certainly how contour deformation works. There's a bind spline and a deformation spline, and it is the difference between those things that produces deformation. It's also how linear blend skinning works, which is actually very analogous to what I just did here. Like, what I just did here, like, talking about the ways in which everything we do is basically built out of matrices. What I'm doing here is essentially the same thing as what linear blend skinning does, just for every single vertex in the mesh. Or, well, actually, for every single vertex multiple times, because then you're blending between the results of different matrices being applied to it. But there is a set of bind matrices that are, you know, usually static, although they do not have to be static. And in an earlier stream, we actually did something with layering deformation that we did by changing the bind matrices of a skin cluster dynamically. You can do that, but a lot of the time they're static. But it is essentially the difference between the bind matrix and the actual animated matrix that actually produces the deformation effect. Or in this case, you could say the deformation effect. It is deforming the transformation of this whole system. They're very analogous ideas, actually, but it's very, very not obvious in the way that Maya presents things to you that they are at all analogous. And here's where, again, it's like thinking in matrices is sometimes complicated, right? And it's likely that you're going to get it wrong and be confused and be frustrated. But it also radically simplifies a lot of the things that you need to do in a rig when you understand how those things sort of like fit together. So, let's see, what's next? Well, this was actually like the main thing I wanted to show this session, was to get all of this working. But we aren't really quite done. Because while we've done this for the finger, and we've got the finger working, we have not done it for the arm. And obviously the arm needs this too, because it's going to be attached to a spine. So let's go do it for the arm. I'm not going to save this because it's just it's a demonstration file, right? Because the arm, as yet, does not have, I mean, it's got the anchor inputs and outputs, like I had already put them there. An anchor and anchor offset, but they are not, well, actually, let me check. Maybe I already did do that. I can't remember. Did I already hook them up? Yeah, this is not helpful. Yeah, I did, actually. I did all. Yeah, you can see me. You can see that I did it here. All right. Well, in that case, I don't actually have to do that to the arm. I already did it apparently. So in that case, maybe it is actually time for us to start constructing the basis of a body plan file, because one of the nice things about componentized rigs is that a body plan file can be created that does not need to be programmatic in any way, right? And of course, if you're writing an auto rig tool, you might well express your body plan as something that is similarly like some data, right? Like, and in that case, it's like a JSON file or something, right? It's something where you're storing some data that basically tells you how to put your rig together. That's certainly one way to construct an auto rig. We can just do it as a Maya file. Not the only option, but it sure makes things easier and simpler. Like, it's worth noting that what we will have constructed, like when I'm done with this, is the equivalent of a full auto rig system that will have been constructed with like 1/10 the effort, or perhaps less, right? That's not to say that making stuff out of Maya files is always the right thing to do. The way that I am doing stuff with this is intentionally meant to be a simple and direct method of doing it. It is worth noting that you could do something with all of these advantages that was more traditional, that did build something in Python, say, or brought in files instead of using references and connecting them together like I was doing, brought in files and and sort of hooked them up together and then unhooked them and kept metadata around about how to do so, and it would actually have the same effect, right? You could do this in a somewhat more conventional way, but the nice thing about doing it this way is it's ridiculously less work than coming up with a system, because again, Maya won't help you, right? To sort of gain all of these advantages and to sort of auto rig in a componentized fashion. It's much simpler to make a bunch of Maya files that fit together the right way. So let's start putting together a body plan. We'll just do it for fingers, and then we will possibly add a spine. Actually, let me take a look at that, because I did start doing a spine, and I don't recall where I left things. I don't think we actually made any changes, so yeah. Here's a spine. Yeah, this spine is clearly not actually finished, and I don't really remember what state it was in. You can see that I've hooked up some things and not other things. So I'm going to leave the spine alone for the moment, and maybe we'll look at that next time after I figure out where I left things off, you know? So yeah, let's start with some arms. Arms and fingers. And then we will probably also, perhaps the next thing to do, and we may not get to that today, is also figure out how to make these reversible. This is also a thing that you can do with componentized rigs that I think is really, really nice, which is one of the other traditional issues that you get either with, I mean, you essentially have to do the same thing you do in an auto rig, which is to look at what data you're feeding in there and figure out what it needs to be for the other side, for like right and left side, right? So it's the same deal with a componentized rig, but you get to do it live and check to see if it makes sense, right? Whereas the loop of authoring an auto rig and trying to figure out how to mirror things properly in it is like I write some stuff, I build it, it is wrong. I write some more stuff, I build it, it's still wrong, right? You know, and we're going to go through the same thing. We're just going to go through it way faster because we've got interactive like feedback. But that is one thing that I think is pretty critical. I have seen a lot of rigs that do things in sort of, I would say, a semi-componentized way, because, you know, the idea of storing, breaking in Maya files is certainly not a new one. I mean, we did it, we actually did it for all of our setup machines, past the first one, I think. Setup machine 2 and game and 3, all, you know, Tagore, you know all about this, right? Like, were constructed out of a bunch of Maya files. What they weren't was systematic about it, because I didn't understand a lot of this stuff at the time. And I was just like, I'm going to make some Maya files, and then we'll write some code that sort of hooks them up together, and, you know, store some stuff in the files, make some stuff in the code. And I didn't have any understanding at the time that having a formalized relationship between these things could gain such tremendous advantages.
One thing that occurs to me is that an approach like this would have made doing the tail a lot easier. Because if you recall, the tail was not a bunch of Maya files. That's something we had to construct in code because, of course, mostly the varying number of segments. But beyond that, the tail had some of the most complicated rigging. And
Indeed.
That was actually one of the harder parts about writing, like the initial TSMG was getting the tail code right. But I think with the modular system, it would have been fine. We would have had this modular thing in a file, and we just would have used as many of them as we needed to, right?
Exactly, because what you would do there for that tail, instead of, I mean, you'd have each segment be its own component, right? And they'd hook up to each other in a certain way, and you just stack as many on as you needed in order to, make your tail, right? It would have been radically easier. I mean, that's sort of the thing that I really didn't understand at the time. Like, there was a lot I didn't understand at the time, right? And a lot of the way that you could make these things that it goes back to formalizing an interface between them, right? I had no understanding of I gained most of my understanding of I guess programming technique, right? Largely from you subsequent to that point, right? Subsequent. Did I use that word correctly? That's after.
Yes,
I did. All right, just checking. But yeah, I mean, I basically, I didn't understand those things at the time, and it ran into that issue of, like, you certainly understood that stuff, but you didn't understand a lot of the rigging stuff. So, like, we were, like, the information to do this better existed between the two of us, but not in any one brain. Right.
Yeah. Well, that happens with us sometimes. I mean, we were talking about that earlier, right?
Yeah.
With the ephemeral system, that there is a bit of that as well. There's some stuff I don't quite understand, and there's probably some simplifying ideas in there that if I understood some of the things you understand as well as you understand them, I think that I might have an easier time finding some of those simplifying ideas than you, because I know some of these patterns in code. But
indeed,
it is what it is, right?
Right. Exactly. What Tagore is referring to is that the ephemeral system's graph is built in a certain way, and I had sort of conceptualized a way of building that graph, but it is often true in programming, and, like, this is an example, right, that you gain enormous advantages from finding the right structure for something, right, that something can, like, it could be, it's actually kind of surprising. I would not have guessed this before I started doing programming myself, that the difference, or, I mean, really, I have been all along because I've been a rigger, but, the difference between the right structure for something, as we have, like componentized rigging is a perfect example. Like, we were sort of, the Senate machine was sort of, like, kind of vaguely componentized. It had some rigging in files, but formalizing that, like, having the right structure to have the pieces communicate enormously simplifies the problem. And it's actually kind of crazy just how much. Like, the difference between having the right structure and not having the right structure can be like an order of magnitude of difficulty. And I wouldn't have understood, and I absolutely didn't understand that that was true. That you could have such a huge difference between getting it right and not getting it right. And so when we're talking about the ephemeral graph, we, there's probably some it works, and it actually works great, but it's over complex in the way that it's written. There's some underlying structure that would make it a lot less complicated.
I would say it's overly specific.
Yeah.
I would say it's overly specific. Yeah. In fact, it knows a little bit too much about. I think there are some principles. It's something I think we should look more closely at some point. But perhaps not right this instant.
Yeah. Well, right. I mean, we have a lot of other stuff to do, including adding more features to the ephemeral system, which I will hopefully be. We recently converted into Python 3, and that was a whole thing. It has a bunch of other sort of maintenance to do. Now that we've sort of gotten through that, I'm going to start adding new features to the system again, and I am pretty excited about that. I've kind of been meaning to get to that for a few months, actually, but life being what it is, sometimes you have to do stuff like convert all your code to Python 3 first. That wasn't really much fun. But that's really neither here nor there, and not really the thing that we're talking about right now. So anyway, I'm going to ignore this spine for the moment, because I need to go back and take another look at it, but I am going to start making this body plan file. Now, in this case, I'm going to make a point of using very specific namespaces, because ultimately what's going to need to happen is that these things are going to have to get baked in some fashion. And the baking is necessary, because what we don't want users to necessarily have, right? So you have this situation where each one of these boxes containing like a bunch of rigging is, it's a separate reference right now. That's how it works. And a separate reference is not something you want to be passing on down the line to the rest of your pipeline. Like if you have animators interacting with a file, referencing into your actual animation scene, a file that itself contains a whole bunch of sub-references, this is asking for a wide variety of different kinds of trouble, right? So we don't want that, right? We want to present people with something that can be flattened. And if you're using the reference method, one of the things you're going to have to do is get rid of all these namespaces, because you don't want a million sub namespaces either. But for the moment, because that's sort of what the namespaces are very effective at, is presenting you with essentially sort of a tag that's like, this one is the left arm as opposed to the right arm, right? So I am going to actually, I'm not going to do the underscore because we can just turn colons into underscores at a later time. I'm going to be using the selected namespace as parent, by which they mean root, and I'm going to add left as a namespace, or actually, it should really be left arm, actually, because that's where what is this thing will come from. That's sort of the namespace, right, of this particular arm. You have multiple arms. You at least have a left and a right one, so most of the time. So you need to disambiguate them. And let's bring in our left arm. Okay, so, which is now getting, everything's getting prefaced with left arm, and as it should. There we go. Apparently it doesn't want to select things. Because we do not yet have our spine, I'm not even going to bother moving the arm into place. Like, we'll figure out what makes sense to sort of be a default position for this stuff, at that time. And let's bring in the finger. We're actually going to, I probably should have just saved the earlier one, because we're just basically going to have to do the exact same thing that we did then. And in this case, what I'm going to do is bring in a whole bunch of fingers, and they're going to be like, 5 fingers and a thumb. No. I need your options, please. Thank you. Probably should just use the keyboard equivalents for that one. No, I really do need the options. Oh no, I clicked on the wrong thing again. Now, one of the things we will do, here's one thing that's really worth noting about this that is a little different. Although it's not an uncommon thing to do in rigs, to be fair, but it is a little different than the norm, or what we've seen a long time, which is that each of these components will remain fully in world space. There is not going to be a point at which we have at which these things themselves ever get put into a more complex hierarchy. There's no reason for them to, because we are essentially just going to, in the method I just showed, like, we're just going to be driving the inputs of each of these components. If you put them in a hierarchy beyond this, it would actually mess it all up. You get double transforms and stuff. And this is actually not only, I think, a perfectly fine thing to do, it's actually a pretty good thing to do, because you've got these one of the things that is actually very unfortunate, I think, about the hierarchy-centric structure of scenes and the outliner in Maya, and everything. One of the things that I think is actually kind of like I would like it to not be that way, is that it centers this idea of a hierarchy as being something essential, and that actually really isn't, right? I mean, you could make a rig. I mean, it's not really a great idea in Maya, but you could make a rig where everything is in world space at all times, just being driven by various, DG connections. And in some ways, the cross relationship between the DAG and the DG, the hierarchy and the the node graph, and the fact that these are kind of two different things, becomes very awkward. One of the things that's very awkward is, note how I put this in a node called components. Like, I created a hierarchy there that does nothing. It's there for organizational purposes, because in the context of Maya, we think of nodes and the hierarchy both as, the actual hierarchy that behaves the way a hierarchy is supposed to, and as an organizational feature of like, we don't really have another concept of folders in here or something. And I actually really think that is a questionable way of doing things. I think that the question of the behavior, and ultimately what you're doing with a hierarchy is saying, what are the behaviors of my nodes? And this is a really different question from what is the organization of my nodes. And conflating those two things makes things very awkward. So it's really okay to just be like, yeah, the fingers are each of these like sort of totally separate hierarchy things. They don't actually need to be organized in any other way, that I'm just going to put them in a components folder, as it were, quote unquote, right? Not really a folder. It's kind of a questionable way to do things. And I'm not going to move them around in any way at all, right? All I'm going to move are the guides, which specifically are the bases of the guides. Although, actually, before I do this, here's something I may want to change about the finger. Here, before I do anything else, let me actually save this. So I'm gonna create a new folder called body plans, and I'm going to call this one it's a standard body plan. I'm just gonna call this like standard biped. Maybe we'll change what it's called, but for now, like, that's fine. Which is, when we were building the finger, we made the controls, the guides, hierarchical. Note that is not true of the arm, right? I'm sort of moving all this stuff around, and this isn't hierarchical, right? But the fingers are, and the only reason I did that is because at the time, when we were busy doing a bunch of other stuff, I wanted to skip over the part where I have to actually set up the relationships here. Because note that nothing in this system makes the guides change their orientation. That's something that I did to the guides as essentially a way of helping the user. Because one of the things about this system is it does expect certain things of the guides, i.e. that they be aligned, right? So in the case of something that's meant to be IK, they need to be aligned in a certain way to maintain their orientations to be planar. And the way that I've set that up is I just constrain the guides in various ways in order to make that happen. The guides have, there are some constraints going on in here, aim constraints that are essentially forcing the guides to always maintain that orientation. And we didn't do that with the finger, but arguably we should, because if we don't, it means that when you are manipulating these finger guides, you have to do it hierarchically, and you may not want that. You may want to be able to freely move these around. Actually, you probably do. So in order to do that, we need to do something a little bit different with the guides. And maybe we should do, before we go positioning anything, I think maybe that is something we ought to do, because it might change how we position it, and it is, probably we don't want the fingers to be stuck, the finger guides to be hierarchical. The reason, in case it isn't clear, the reason I made them hierarchical is because, assuming you lock some of the channels, that ensures that they aim down the axis in a way that you otherwise have to ensure using some constraints, right? So I would like to go fix that. However, we are also, I think, because that's a little bit of a thing, I think we may be approaching the end of this session. As I sort of mentioned, we're going to try to be a little shorter from when I was doing the massive 2-hour sessions, in the last batch. And so I think this is kind of a good breaking off point, because a lot of the basic points of like, here's how components fit together. Sort of like we've gone over a lot of that stuff, and we've gotten, I think, a better picture of that than I think I was able to give last time. And that was really my goal with this session. So I think it may actually make sense to start next session with, here's how we go about manipulating some guides to give a better sort of interface to the user. Because that's really kind of a separate topic. And then we'll just continue like, going ahead and assembling a body plan, and then, finishing the spine probably. And then from there, probably, moving on to the leg. Once we have the leg in place, oh yes, and we'll also have to make them reversible. This is not going to be that difficult, but it'll have a few additional wrinkles. Once we have that working properly, including with the feet, which are going to be a little more complicated because they'll have a reverse foot rig. So, they'll need some additional stuff beyond sort of what Contour naturally does, but it won't be that complicated. We will have a full usable componentized rig that can be adjusted, on the fly, and it will be very nice. Probably won't be too many sessions past this one, actually. This is why I love componentized rigging.
Yeah, we should maybe throw that up as a download somewhere, huh?
Oh, absolutely. A, we should do that, and B, then we can sort of like go from there to be like, making this something you can just access from within Contour.
Yeah. Well, right. Eventually, we are going to add the ability to have body plans to Contour, and we're going to use basically these techniques to do it. But just for people that are interested in,
absolutely, yeah,
in taking a look,
Yeah, and I sort of do expect that these files will form the basis of that. I mean, we may modify them, right? Like depending on what our needs are for that feature, but this will form the basis of that, I think. So anyway, yeah. Once again, next week we'll be continuing with our, our dive into componentized rigging with Contour. Please like and subscribe, and tell all of your friends that they absolutely must see this because it's astonishing and will change their lives. I will see you guys then. Thank you very much for joining us.
Okay. Thank you very much, Raph. And thank you everyone who came by for coming by. And we'll see you later.
All right. Bye.